Hello everybody. Today we're going to go over some basics of trig, angle measures. So we were going to switch from degrees to radians, radians to degrees. We are also going to draw some angles in standard position. And then of course talk about arc length. So you may know all this already, but just as a quick review, reminders, some things you may have forgotten. So we're going to talk about degrees to radians, and pretty much we will live in the radian world once we kind of switch over. So the big deal is that all the way around the circle is 360 degrees, but in radians it's 2 pi. So obviously half of that is 1 pi. So half of a circle is 1 pi. So because we want to deal with the smallest numbers, we will be dealing with that relationship 1 pi to 180 rather than 2 pi and 360. That's just the numbers are too big, so basically it's just reduced to 1 and 180, 1 pi rather. So the most common unit for angles is the degree measure. Obviously, that's the one you've seen probably the most. There is no symbol for radians. A degree is 1 out of 360 or 1/360th of obviously of a full rotation, so it's very small. A radian is a little bit larger. To draw an angle in standard position, we always start right here. We start from the positive x-axis. We start right here, and you can see over here in this diagram that that's where it shows you that it's 0 degrees. When we rotate up and around. So when you go to draw it, you go up. That's a positive angle. When you go spin down, this is a negative angle. So up is positive, down is negative. Let's just go through a few. I'm going to be real picky about all the parts. So an angle has 2 sides. So we have where it starts. We also have where it ends. Now at 65 degrees, you can just guess. It doesn't have to be super great. It's just going to be somewhere in here. Obviously, we know it's less than 90. So you draw your terminal side. That's called the terminal side. And then you also have to draw the angle or the direction in which you spun. So we spun up, or we took this thing. You can think of an angle as kind of a spinner, and it just kind of spins around and can land anywhere. So we want to show the direction in which the angle came from. So for 320 degrees, obviously here's 180, here's 270. So 320 is not quite all the way around. So we start from here. You don't have to draw that. I'm just showing you because it's hard to see because it's black on black. So we're going to spin around, and we're just going to land somewhere in that 4th quadrant. 415, that's clearly more than 1 rotation. So it's just a tiny bit more than 1 rotation. It's 75 degrees, so we're not quite, we're still in the 1st quadrant. So when you have to do more than 1, please make sure that it spirals out so we can see that you went around 1 full time and then a little bit more. So don't make it spiral right on top of itself like that. You can't tell how many times you went around. For negative angles, remember this would be negative 180, and so it's not quite that far, so we're going to go over here, and then of course that's the angle. This is the part right here that we just drew, so that would be where the angle is. This is the angle. Negative 15, obviously very small. We're just going to go down a tiny bit, and then it stops right here. And negative 210, again we're going to land over here somewhere, and the direction in which we went is that way because we spun down. So all of that is required, and when you draw this, I know that XY axis was there, but you'll have to draw both the X and the Y axis as well. Converting from angles, either from radians to degrees or from degrees to radians, your calculator does a really nice job with this. However, you will have to take care of the pi symbol yourself. So it's all about the pi. In a radian measure, the pi goes in the numerator. So put the pi in the numerator, the 180 in the bottom. We are multiplying. I don't know why I wrote it like that. You can just put it in the calculator, 60 divided by 180, or make it a fraction. So you get 1/3, but you have to put the pi back in there. If you put the pi in the calculator, it treats it like a decimal, and you'll never get the calculator to switch it to a fraction for you. So again, if you don't know how to reduce that or don't want to reduce it, don't bother. 160 divided by 180, make it give you back to a fraction. So we go to math, enter, enter. And then you put the pi symbol back in the numerator. The pi symbol will go in the numerator. So this is 8 pi over 9. If it's negative, it just stays negative. We're going to multiply by pi over 180. And so this is negative 7 pi over 6. Again, pi over 180, and then just reduce the fraction. All you need to do is put in the 75 divided by 180, and then make it switch back to a fraction for you. Negative 5 pi over 12. Now, to go the other way, to go 2 degrees, well, we want to get rid of the pi. There's no pi symbol in degrees, so that tells you to put the pi on the bottom because we're going to cross these off, which means the 180 goes on the top. So that's how you know kind of where to put this. So this would be 5 times 180, and then you could hit enter, and then we want to divide that by 18. Or you could do 5 divided by 18 times 180. It's up to you. Again, the pi symbol is not there. Do not put it in the calculator. If you have to round, we'll go to 2 decimal places. But most of the time, it works out pretty well. You don't have any kind of, you'll have whole numbers, I guess is what I'm saying. So again, the pi's cross off, and this would be 420 degrees. So again, put the pi in the denominator because that's going to cross off with this numerator. And this is a negative angle, so it stays negative, negative 135. For the degrees, please make sure that you put the degree symbol, always. There is no symbol for radians, and that's how we'll be able to tell the difference. And then for this one's kind of a big one. We have negative 855 degrees. Now, because we can really go all the way up to infinity, we can go all the way to negative infinity for these angles, because we don't know how many times it's going to spin around. Angles have an infinite amount of names. So if we think about this angle right here, and I think they're trying to use this as a demonstration. So this spot, this 90 degrees. So I can get to the 90 degrees the short way, and I can just go right up there. Or you can spin down and around and get to 90 there. Or if you were super extreme, we could go up and around and then land there. Or we could go down and around and past it. So we can get there lots and lots of ways. These are all coterminal. They all have the same location, but a different number. But it's this that lands in the same spot. So you can kind of approach this a couple different ways. I'm going to draw them because I like a picture. So if we think about 305 degrees. So again, when you go to draw this, it's the whole thing. I need all 4 quadrants. And then 305 would be somewhere over here. And you're basically, or not basically, you are, this space right here, you are 55 degrees away from being all the way around. So going up and around 305 or going down negative 55 lands you in this same exact spot. So yes, these are coterminal. If we think about 30 degrees, so 30 degrees would be right up here, and we just go right there. Now, negative 170. Nope. All right, that's going to be over here somewhere. Not quite to negative 180, so this is a no. Radians. Please don't switch back to degrees. It's going to be kind of difficult to sort of always translate for yourself. Let's start thinking in radians. Pi over 4 is 45 degrees if you're going to switch it, but it's small, so it's in the first quadrant. Now, negative 9 pi over 4. If we count, if we put this in fourths, right, this is 1 pi. So we can think of this as 4 pi over 4. That's the same thing as 1. And then when you go over here and come over to the other side, you just double it because that's 2 pi. So negative 9 pi over 4 is all the way around and a little bit more. So here's 8 pi over 4. And we want to go a little bit more. Oh, no, they're not coterminal. 3 pi over 2. Again, let's do my little trick again. Let's call this 2 pi over 2. Well, your pi over 2s are your 90, 180, 270. So 3 pi over 2 is basically right here. It's 270. So that's where the angle is. We don't have to draw it because it lands right there. Negative 5 pi over 2. Well, if we double this would be 4 pi over 2. So if we think about going negative, we're going to go down. So there's 2 pi. Here's 4 pi. We just need one more, and it is right there. So negative 5 pi over 2 and positive 3 pi over 2, yes, these are coterminal. To do this the other way, if you're looking for answers, it's pretty easy. You just add and subtract 360 degrees. That's it. So 265 plus 360 is 625. And of course, you want to do it in that order. You want to go 265 minus 360 because you want it to come out negative. That would be a negative 95. And again, the degree symbol is necessary. Now, when you do this in radians, it's a little bit different. That's why I put 2 radians on here. You want to add and subtract 2 pi. But in your calculator, you do not want to put the pi. So you do 7 divided by 6 plus 2, and then make it to give you back a fraction. So you hit enter, then you go to math, of course, and then enter times 2 again. So 2 times. This will give you 19 pi. Oops, not 119 pi. Just 19 pi over 6. Can't write it for some reason. So then you would do the same thing. You would go 7 over 6 minus 2 and make it give you back a fraction. So this would be negative 5 pi over 6. You take care of the pi yourself. Now, of course, with this one, it's already negative, but when you add the 2, you get 11 pi over 8. Oh, I can't write. And then if we subtract the 2, again, it's 2 pi, but you have to take care of the pi yourself. It's negative 21 pi over 8. Big deal on that. Don't let the calculator do the pi symbol for you. You do that yourself. Now, for arc length, if you did this in geometry, sometimes it seems complicated in geometry. We're not going to make it that difficult. The formula is n over 360 times 2 pi r. So basically what arc length is we're going to cut this off. Like imagine we come over here and we just cut this right off of our circle, and then we flatten it out and we measure it in a straight line measurement, inches, centimeters, whatever. We don't use degrees. So there's arc measure, which is the degree. Like this might be 100 degrees, and then that arc would also be 100 degrees from the central angle. We want to flatten it out and call it maybe 2.67 centimeters or something. So it's a completely different measurement. Put this in the calculator, and as you can see, we're going to round to 2 decimal places. These are almost always decimals. On occasion, you might have them work out to be a whole number, but not really. So the 330 over 360, this is basically what fraction of the circle is it? Is it all circle? Is it a 1/4 of the circle? So that gives you the fraction, and then you multiply by 2 pi times your radius, which is 6.2. Now in your calculator, the pi key, you go second, and then that little caret key or the power key, and that will give you the pi. Now you can put in the 3.14 yourself. Probably easier to just use the pi key. We're going to 2 decimal places, so we have 35.71 yards. So again, just one more time, 120 over 360 times 2 pi 1.8. Again, super, super simple. I would go straight across the top, alt this, and then hit equals, and then divided by 360, and then hit enter again. And this is 3.77 feet. Pay attention to your units and use the units. Here's more of an application of it. Same idea. So we have a merry-go-round that rotates 2,808 degrees per ride. So again, a merry-go-round. It's going like this, right? So you go around probably lots of times. How far would the rider seated from 8 feet from the center be? So that's your radius. So we have 2808 divided by 360. Times 2 times pi times the radius of 8. Again, straight across the top, hit enter, divide by 360. We get 392.07 feet. So try the homework, use your calculator, make this easy in terms of the fractions. Again, make sure you take care of the pi yourself. Don't put the pi symbol in the calculator for the converting, only for arc length problems.